geometry students. Mr. Zacek back and better than ever here. We're wrapping up Unit 10 today, Lesson 7. We're going to talk about the area of a sector. So when we're talking about a circle, the area of a circle is the product of pi and the square of the radius. So sometimes you'll hear me say apple pies are 2, just that little like circumference, cherry is delicious pie, apple pies are 2, just as a way of remembering those two formulas. So when we talk about a sector, we're essentially talking about a slice of the pie. So we name the sectors using the arc endpoints here and the central, the center. So sector RPS, that's like this chunk of the pie and it goes to the middle. And it's very similar to how we found the length of an arc. We're going to set up a proportion because it's a fraction of the total area. So the area of a sector divided by the area of the circle equals the central angle divided by 360. Okay, so let's go do some examples. What is the area of a circular wrestling region with a 42-inch diameter? So let me just draw a circle here. So we've got a circular wrestling region with a 42-inch diameter. So the diameter and what is the area of the circular wrestling region? So all this is area of a circle. So 42, now whenever you see the number written right at the center, that indicates it's the diameter. So diameter is 42. If it was the radius, it would be written off to one side. So we always find the radius as 21. And so area, apple pies are 2. It's the radius squared. So the area is pi times 21 squared. And so we're going to leave it in terms of pi, which means when we square it, we're not going to put the pi in at this point. So that's 441. So the area would be 441 pi inches squared. Pi. Okay. If the radius of a circle is halved, how does the area change? So let's look at an example. Let's take something like, here's a circle. Let's say the radius is 10. So that would be, the area would be pi times 10 squared, which would be 100 pi. Well, if we took that area or that radius in half, let's say it was 5. So now the area would be pi times 5 squared. So that area would be 25 pi. So how do those compare? What happens to that? Well, 25 pi over 100 pi is 1/4. So if the radius is half, the area is 1/4. All right. And that's very along the lines of the similarity that we had before, the questions that we did before. Okay, what is the area of the sector of GPH? Express it in terms of pi. Okay, so here we go now. So we got our angle. Remember, the arc and the central angle are the same. So the radius is 15. That means the diameter is 30. Area is pi times the radius squared. So this would be pi times 15 squared. So the area of this circle would be 225 pi. So the area of our sector, I'm going to call it x, over the total area equals the angle over 360. So now we're going to cross multiply. We get 360x, and I'm going to multiply 72 times 22. So 72 times 22 is 1,584. So 1,584 pi. Then we're going to take that number and divide it by 360. So that number divided by 360 is 22/5. So that would be 22 pi over 5. That would be the area of the sector there. Okay, so pretty simple, right? Just, same kind of concept. It's a fraction of the total area. and we're using the angle to determine that fraction. All right, so a circle has a radius of 4 inches. What is the area of a sector bound by a 45-degree arc? So we're saying, like, if we take this little wedge, this is 4 inches and this is 45 degrees. Okay, express your answer in terms of pi. So the radius is 4. That means the diameter is 8. Area is pi r squared, so we're going to use the radius, which would be 16. I forgot to square it. I just jumped right to the answer. Okay, so we're going to try to find the area, the part of the hole. The hole is 16 pi, 45 over 360. So we cross multiply, we get 360x, and then we're going to do 45 times 16. I should say the cross product property. Okay, so that's 720 pi. We're going to divide by 360. So the area of our sector would be 2 pi. Inches squared if we want to put units with it. Okay, so same kind of concept here, except for in number 5. We're given this angle, and this angle isn't the shaded angle. So if we do 360 minus 260, that'll give us 100. So that angle would be a 100-degree angle. We want to identify that our radius is 6. That means our diameter would be 12. So in terms of the area, did I just pull out my cable here? Let me just check here. Okay, sorry about that. I thought I had pulled the cable out of my microphone, but I think we're good. So area is pi r squared, the total area of the circle. So in this case, our radius is 6. So the area of the circle would be 36 pi. Okay. So we're trying to find the shaded region. I'm going to call it x over the total area, okay, equals 100 over 360. So we're going to just do the cross product property. 360x equals 3600 pi. Okay, we're going to divide that by 360. And that is going to equal 10 pi. Okay, so 10 pi would be the area of that shaded region. So hopefully you're feeling comfortable with this. We're going to switch it up a little bit here. In number 6, we're going to find the central angle of a sector that has an area of 18 pi with a radius of 10 centimeters. All right, so let's begin by drawing a circle. Come back, circle tool. Okay, so we've got a circle, and the radius of this circle is 10, and we've got some sector that is 18 pi. That's the area of the sector. So if the radius is 10, the diameter is 20, area is pi times the radius squared, so pi times 10 squared. The area for the circle would be 100 pi. So in this case, we know the area, so that the sector is a part of the total. What we're trying to find is the angle, and the total angle around is 360 degrees. So we cross multiply, we get 100 pi times x equals, what's 360 times 18? Let's see here, 360 times 18, 6,480. So 6,480 pi. And we're going to divide that now by 100 pi. So the pi's cancel out, and when you divide by 100, it's like moving the decimal point 2 places to the left. So that would be 64.8 degrees would be the central angle that subtends that arc. Okay, we've got one last question here. A little bit of a different question. A circle has a radius of 6 inches. What is the area of a sector bound by a minor arc that measures pi over 6 radians? Round your answer to the nearest tenth. Okay, so in this case, What's different about this one, so let's draw a circle. Circle is 6 inches for the radius. Okay, so radius is 6 inches, diameter would be 12 inches, area is pi r squared, so that's going to be pi times 6 squared. So the area of the circle is going to be 36 pi. Okay, now what is the area bound by the minor arc? So we're in radians here, so we could do this a couple ways. We could convert radians to degrees, or when we do our area, which we're trying to find, part over the total, instead of putting 360, what is 360 in radians? So 360 in radians, 360 degrees, equals 2 pi radians. So we could put it over 2 pi in this instance. Okay, so if we cross multiply now, we've got 2 pi x equals, I'm just going to write this out, 36 pi times pi over 6. Okay, now when you're multiplying fractions, we multiply the numerators. So this would be 36 pi squared divided by 6, which would be 2 pi x equals 6 pi squared. Okay, well now if we divide by 2 pi, and we divide by 2 pi, 6 divided by 2 is 3, pi squared divided by pi is just pi. So what is the area? The area to the nearest tenth, we would just take that number, and 3 times pi is 9.4. Okay, so x equals 9.4 inches squared. All right, little trickier one because the angle was given in radians. So if we can remember that 360 is 2 pi, then in our fraction that we set up, instead of putting in 360 degrees, we can just put 2 pi in. So if we remember the conversion, that's helpful to us, or sometimes just remembering that specific conversion can be helpful, that 360 is 2 pi radians. All right, this wraps up this unit, and we're going to be digging a lot deeper into circles in our next unit, so I'll see you back here then. Let's keep on asking questions.